Hi guys, I've been asked to cover the topic of gyro compass, and this is my effort towards it. I'm going to cover this topic in 3 or 4 short videos because understanding how a gyro compass works on a ship is a bit complicated, at least for me, and I've tried my best to simplify it for you to make it simple enough for you to understand how a gyro compass works and yet at the same time not really go into the technicalities of it. So this is only for mariners knowledge, for seafarers or for deck officers who are working on the bridge, and this will give you sufficient knowledge to understand how basic a basic principle of operation. It's not advanced knowledge on it, so my apologies if you were expecting something advanced here. I'll try to keep it simple, yet at the same time try to explain the principle of operation behind it. So today in this video I will just cover the regulations, what is a gyro compass and what is a gyroscope. In my next video, I'll go deeper into what a gyroscope is and what are the principles and properties of it and how it is converted into gyro compass and so on and so forth. So I'll make a series of 3 or 4 videos for your understanding. All right, so let's start with the brief history of the gyro compass. So it was in 1885 that Marinus Gerardus patented the first gyro compass, which however did not work properly. In 1889, Captain Arthur Krebs designed an electrical pendular gyroscope for the experimental French submarine Gymnote. It was in 1903 that Hermann Einschütz-Kampf uh, constructed a working gyro compass and obtained a patent on the design. But it was in 1908 that he worked with the American inventor Elmer Ambrose Sperry, who also went on to become a very famous name. And I'll talk about how Sperry contributed in my further videos as well. But they patented the gyro compass in Germany as well as in the US. Uh, Hermann Franz was a German scientist and inventor, and in his quest to navigate to the North Pole by submarine, he became interested in the concept of the gyro compass. In 1905, he founded a company, the first firm to manufacture the gyroscopic navigation instruments, which he designed. One of his staff was Maximilian Schuler, who made the fundamental discovery of Schuler tuning. So if you don't know what Schuler tuning is actually the principle behind many of these inertial navigation systems, which took into account the curvature of the earth and helps to keep track of the ship's position as well as direction keeping, courses, so on and so forth. All right. So what was the purpose of the gyro compass? So the purpose of the gyro compass was that an improvement over the magnetic compass was required, because a magnetic compass basically always points towards the magnetic north. Now magnetic north is not a fixed point on the Earth's surface. A magnetic north keeps on changing due to the change in the Earth's core. It doesn't stay at one point. So if a magnetic needle is pointing towards differing magnetic norths, it cannot be considered a reliable means of direction keeping and course measurement. Of course, magnetic compass is the backup steering compass as well as the direction keeping and course measurement instrument on the ship, but it is not the primary means of doing that. The primary means of doing that is gyro compass, because gyro compass, being a man-made equipment, was made because the gyro compass could point towards a fixed point, which is considered the true north of direction 000 degrees. It doesn't change from that north. So it's unlike a magnetic compass where the magnetic needle can keep pointing towards differing magnetic norths depending on the Earth's core, and the magnetic needle on the ship also gets influenced by the Earth's magnetism as well as the ship's magnetism. The gyro compass doesn't go through all these things. So gyro compass can be considered to be a reliable means of direction keeping and course measurement. The reason is because it doesn't get influenced by the Earth's magnetism, and at the same time it always points towards a fixed point, which is considered the true north. So all courses, all direction keeping can be measured from that point, and that is why all the nautical charts datum is based on the true north. True north is considered to be a reliable means of course measurement on the ship. All right, and that is why a gyro compass was invented. In terms of regulations, all ships over 500 gross tonnage are required to have a gyro compass, which shall point to the true geographic north all the time. A magnetic compass cannot be considered to be a replacement of the gyro compass. A gyro compass needs to be there even though a magnetic compass is present on the ship. Magnetic compass is a backup system. The gyro compass will be the primary means of steering and course measurement. The gyro compass fitted on the ship must also be able to transmit data to all instruments that require this information. By all instruments, we mean GPS, radars, RPAS, electronic chart plotters, so on and so forth. All ships over 500 gross tonnage shall also have a gyro repeater. The means of the gyro repeater should be such that not only they should be pointing towards a true geographic north, but the arrangements of the gyro repeaters should be such that the officer on the watch on the bridge shall be able to take bearings all over 360 degrees and all over the horizon. The entire horizon should be able to be covered. However, if ships are less than 1600 gross tonnage, they may be fitted by such means if it is practical and possible to do so. All ships over 50,000 gross tonnage shall also have a rate of turn indicator, the working principle of which is quite based on the gyro compass itself. The figure of 50,000 gross tonnage is being chosen because it's these big ships that are required to monitor their rate of turn because of their handling characteristics. It's difficult to handle such big ships in ports when they're coming in. The rate of turn is monitored by the pilot as well as by the mooring boats, the tugboats as well, because in delicate operations or mooring operations or maneuvering operations, it's keeping an eye on the rate of turn helps in the berthing and unberthing of these big ships, and that's why all ships over 50,000 gross tonnage should have a rate of turn indicator. Ships less than 50,000 gross tonnage may or may not have a rate of turn indicator, depending on, of course, if the company or the class wants to supply it. All right. In terms of importance, the gyro compass does send data to critical navigation equipment such as the steering, the autopilot systems, radars and ARPA feeds, electronic chart plotters. You can also include the AIS as well as the satellite communication dishes as well. A gyro compass is pretty much based on the working principle of a gyroscope. So before I finish this video today, I want you to understand what a gyroscope is, because it's the gyroscope and the movement of the gyroscope which basically was the foundation principle of how a gyro compass will be able to keep a fixed direction from which the courses can be measured out. So a gyroscope, you understand the gyroscope now, and in the next video I'll be talking about the properties of a gyroscope and how the properties of the gyroscope was used to make a gyro compass seek and settle at the north direction of 000 degrees. All right, so if you look at a gyroscope, I'll show you an animation as well on the last slide today. So a gyroscope has actually three axes of freedom. You have the spin axis, the horizontal axis, and the vertical axis. So in the next slide, you will see that it's much better here. And you can see that the disc, the yellow disc, is spinning around the spin axis. And then the gyroscope also has freedom of movement about the vertical axis as well as the horizontal axis. Now, why all this is important is because I'll just give you a, before I end this video, I'll give you a quick brief on what the next video will cover. So basically a gyroscope works on the principle of angular momentum. So it's like a spinning top. All right. So based on the mass of the rotor, if the gyroscope can gain enough RPM based on the mass of the rotor, so that's where the angular momentum. So every gyroscope or every spinning top may have different mass. So there is not a fixed RPM, but depending on the mass of the rotor or mass of the gyroscope here, if it gains enough RPM based on the moment of inertia and principles of angular momentum, it can be made to point to a fixed direction. And you must have noticed this on spinning tops as well. If you use a spinning top and throw a spinning top on the ground, as soon as it gains the maximum RPM, it keeps spinning, doesn't fall down. It's only when the spinning top starts to lose its momentum that it falls down. So if you guys have seen the movie Inception, I don't know whether you have seen that movie or not, but there's a scene where spinning top is used and the spinning top keeps spinning, and it's only when the momentum dies down that the spinning top starts to wobble and fall down. So that is the principle behind it. So however, it's not such a simple explanation. So although a gyroscope may gain enough RPM to be made to point towards a fixed direction in space, unfortunately it's not that simple, because the Earth's movement below it has an impact on the gyroscope. So, and we'll talk about that and how the Earth's movement affects the movement of the gyroscope, and how over a period of time measures were developed to counteract for this Earth's movement, so that the spinning gyroscope keeps pointing towards one direction and settles there, so that direction keeping and course measurement can be done for the gyro compass. So we'll talk about that in my next video. I'll keep this video short, otherwise you guys will lose interest. So I'll see you soon with my next video, guys. Keep watching and keep subscribing so that you get notification about my future videos, and all the best with your studies. Study hard, and I'll see you soon.